Here's the great news for today, y'all. Today is going to be pretty straightforward, pretty easy. Hopefully you guys have all seen this before in your geometry class. So what we're looking at is using sine, cosine, and tangent to figure out either missing side lengths or missing angles. Today we're just going to focus on the side lengths. Hopefully you'll find it pretty straightforward. The number one thing that you guys need to remember, I'm sure you've heard it before, is so, ka, toa. So you guys have seen the video already on the first half of this lesson. We did review that sine, cosine, tangent are those ratios, SOHCAHTOA. So here's the deal. When you guys look at this, we're finding the missing side length. The first thing that you need to do is identify which pair of sides you are given. So first off, if we're looking at this 18 degrees, the opposite side is the 12. The x in this case is your hypotenuse because it's across from that right angle. So if we're dealing with the opposite and the hypotenuse, that tells us that we're going to be using sine. So what we would need to do is we would need to go ahead and set up our equation. So sine of the angle is equal to the ratio opposite over hypotenuse, so 12 over x. Now, one of the big things that you need to make sure that you are aware of and that you are being mindful of is making sure that you change your calculator back and forth from degrees to radians based on whatever it is you're looking at. So for example, in this case, we're looking at degrees. So you want to make sure you go to mode in your calculator, make sure that your mode is in degrees. If you have any questions about that, please make sure you ask early, okay? Otherwise, you're going to get wrong answers throughout. So as you're looking at this, keep in mind the way that you would go about solving for x in this case, we're going to multiply each side by x to get rid of it from the denominator. And so at this point, you've got x times the sine of 18 equals 12. And then from there, you're going to divide each side by sine of 18. So we have x equals 12 divided by sine of 18 degrees. And all you're doing is punching 12 divided by sine of 18 in your calculator. And when you do so, we're going to round lengths either to the 10th or 100th. In this case, I went ahead and rounded it to the nearest 10th. So 38.8 meters. Now, when you look at this, okay, again, let me just kind of review your steps. You're going to figure out which pair of sides you're given, set up your equation accordingly, and then go ahead and do your not cross multiplying. Set up your equation and then go ahead and do your solving. So let's take a look at the second one. I'm going to let you guys actually try this for just one moment. So hopefully you're recognizing with respect to 42 degrees, you've got the opposite side and you also have the adjacent leg. So that tells us that we're going to be using tangent. So we have tangent, sorry about that. We have tangent of 42 degrees equals the opposite over the adjacent. Again, we're using that TOA. And now, same steps as before, we're going to multiply each side by x to get that out of the denominator. So x times the tangent of 42 equals 10. And then divide each side by that tangent of 42. And so when you type that in your calculator, you would get a value of 11.1 meters. Okay, so again, when you guys are looking at this, the setup is the key, making sure that you're using the correct thing, sine, cosine, or tangent. So slide number 13, but these two problems, these word problems are exactly the same concept. The only thing that's missing is the picture. So what you would need to do is take a minute and sketch the picture based on what you are given. So a nursery plants a new tree and attaches a guy wire to help support the tree while its roots take hold. So first off, let's go ahead and sketch a picture. So we've got the tree. By the way, disclaimer, I am not a great artist, okay? So just kind of bear with me. And then they attach a wire to the tree to the ground, okay? It's an 8-foot wire that's attached to the tree. So this part right here is 8 feet. And to a stake in the ground. From the stake in the ground to the angle of elevation of the connection with the tree is 42 degrees. So think about if you are standing down here, okay? I know that you're not going to be like up against the ground itself, but if you're standing down here and you're kind of spacing off and you look up, that is your angle of elevation. So this is the angle that we're looking at, that's the angle of elevation. So fortunately in this case, we know that that angle of elevation is 42 degrees. They tell us that. And so we are trying to find to the nearest tenth of a foot, the height of the connection point to the tree. So in this case, we are trying to find this value. So now that we have the picture set up, take a minute and go ahead and figure out what it is for the height. So hopefully you were able to find, you've got the opposite, you've got the hypotenuse, which if you're dealing with the opposite and the hypotenuse, you're dealing with sine. So sine of the angle equals the opposite over the hypotenuse. Now in this case, your 8 is the denominator, so we can just multiply each side by 8, and we can type that in our calculator. 8 times sine of 42 degrees. That gets us our x value, which in this case is approximately, again, we're going to the nearest foot, 5.4 feet. All right, the last one. From the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. Okay, so let's talk about this angle of depression. Again, I'm not an artist, so just kind of bear with me. This is my little tower. He's up there. We spot a partner down here. Okay, we've got the triangle going in. Now, you can do this several different ways, but what I would suggest is go ahead and kind of sketch this right triangle, because an angle of depression is if this person up here is looking out on the horizon and then all of a sudden looks down, that's our angle of depression. So that's 40 degrees. It says if the tower is 45 feet in height, how far is the partner from the base? So we could do this. I'm going to do this in red. We're trying to figure out how far is the partner from the base, so we're trying to figure out the horizontal length. The other way that you could do this is you could do, and I'm going to do this in purple here down here, you could do this right triangle, okay? So this is here, and the key is that your angle of elevation and your angle of depression are equal. So if you remember back to geometry, if you've got parallel lines, you've got alternate interior angles there that are congruent, or if it goes the other way, like in this case, you've got these angles that are congruent. So you have alternate interior angles are congruent. That's why this angle of depression is equal to the angle of elevation. Okay, so you could absolutely use the purple triangle. The reason you can use either is because you're going to end up with the same pattern. You're going to end up with the 45 feet. That's not supposed to have a degree there sign. It's supposed to be 45 feet. This is opposite, and this is adjacent. And in the purple, that 45 is the opposite, the x is adjacent. So either way, we're dealing with opposite and adjacent. So we have tangent of the angle, which is 40 degrees, equals the opposite, which was 45, over the adjacent x. And then we can go ahead and finish solving. So we would multiply this by x, multiply this by x. So at this point, we'd have x times tangent of 40 equals 45, and then divide each side by tangent of 40. So again, guys, the last two are exactly the same as the first two. The only difference is you are responsible for setting up your picture. Okay, so this is going to be to the nearest tenth of a foot again, 53.6 feet. And that is our answer. One of the things you want to keep in mind is make sure your answers are making logical sense. So if you have a number that's way too small or way too big, you know you've done something wrong. So just take that extra 5 seconds and process, does our answer make sense? Okay, so hopefully that all makes sense. As always, guys, ask questions, but honestly, this should be a review of something you've seen previously in geometry. So hopefully it all is good. All right, let me know how I can help. Thanks.